Let's work on an extensive trig review. This is part 5 of these videos. Now, for those of you who have the study sheet, I am going to skip a few problems because they're almost the same as some I've done. So let's talk about the next one. It's going to be number 59 if you're following. It says a pendulum of length L, when displaced horizontally and released, oscillates with harmonic motion according to the equation y equals a times the sine of, it's got a couple of parentheses here, and then it's got square root of g over L, and then multiplied by t, plus pi over 2, close parentheses. Y is the distance in meters from the rest position, t is seconds, g is 9.8 meters per second squared, which is gravity, and we are supposed to identify the period, the amplitude, so the period, the amplitude, the phase shift. Let's see what else here. Okay, phase shift. And that's it, I guess. Okay, so let me write the numbers down that are given. T equals time, but I don't have numbers for that one at this point. A equals 0.39 meters. L is equal to 0.49 meters. And I guess G is 9.8 meters per second squared, or meters per second per second. So, first of all, let's do the easiest. What's the amplitude? Well, here's A, here's A. Amplitude, 0.39 meters, okay? Phase shift and period, they all come from here. So let's deal with that. Let's put our numbers in. Square root of G, square root of 9.8 meters per second. Okay, I'll leave the digits off, or the units off at this point. Divided by L. L is 0.49 meters. So 49 meters. Okay. And then times time. Okay, so times time, that's the variable here, plus pi over 2. So there's the angle part. Now, to find the period, we've got a sine function, so it normally is 2 pi, so the period is equal to 2 pi over this, okay? So let me get a calculator out because that's what we need here for sure. We've got square root of 9.8, okay, divided by 0.49. That's our number that's in front of t. Now I've got to take 2 pi divided by that. So 2 pi, I probably should have done that first, but 2 pi divided by this number up here. So let's do that. And so that gives us a period of 0.9834, and our answers need to be rounded to the nearest hundredth. So it's 6.388, etc. So approximately 0.98. Okay, that's the period. Now, last thing is phase shift. So we've got to solve this, set it equal to 0, and solve for t. So if I move pi over 2 over, I've got square root of 9.8 over 0.49 is times t equals minus pi over 2. So if I multiply by the reciprocal, I've got 0.49 over square root of 9.8, not 0.98. So multiply this by 0.49 over the square root of 9.8. Cancel there. We've got t equals, let's see what we've got here. So minus pi over 2. So I'm going to put this up here. Minus pi divided by 2. Then times 0.49 divided by the square root of 9.8. And let's go with the to the nearest hundredth minus 0.25. So that's 5 or more, so minus 0.25, and that is measured in seconds. Okay. This is phase shift, and it's actually going to be in meters. These are all measured in meters. So there is a word problem. It's not that exhaustive. It's just got a lot of words. All right. So number 60, next question, has a temperature in Fairbanks is approximated by capital T of X. So capital T is temperature is equal to 37 times the sine of 2 pi over 365, notice that, times x minus 101, and then plus 25, okay? So T of T is the temperature on day X, so X equals the day of the year. X equals 1 is January 1, means January 1, okay? And X equals 365 is December 31. So there you go. Okay, so estimate the temperature on day 49. So day 49, okay, sometime in February. Let's figure that out. Notice this has pi's in it and such, no degrees. So we've got to be in radians. So I'm in radians. I've got to take 37. Let me get this so you can see it. It's not in very good location. There we go. Okay, so 37 times the sine of, now 2 pi divided by 365, and then multiplied by the square, or by set of parentheses x, which would be 49 minus 101. Okay, so that's going to give us a negative angle in there. That's kind of an interesting thing. Okay, close the second set of parentheses and then add 25. So let's see how this goes. We get minus 3.87. Now, does it make sense that February, sometime in February, would have, like around February 15th or 19th or so, would have temperature in the negatives in Fairbanks, Alaska? Oh yeah. So anyway, minus 3.87 looks like, it's about minus 4 degrees. Okay, now what's this measured in? Looks like it might be in Celsius. I'm not totally sure, but I think it might be in Celsius, that 37 and the 25 and all that kind of stuff. I would have to double check. But anyway, it doesn't even say anything about that. But there's the result. Okay, now let's get out of the word problems for a bit. Let's use identities to write an expression as simple as possible. So this one's number 61. It says the sine of 8x times the cosine of 8x. That's all we're given. Well, when I look at that, I think about the fact that the sine of 2 theta identity is equal to 2 times the sine of theta times the cosine of theta. And I just recognized that. So if I divide by 2, then I could say, oh, okay, well, theta matches the 8x. Okay, so if theta matches 8x, then let's go here. We're going to have sine of 2 theta over 2. So this is the sine of 2 times 8x, and it's all over 2. Now, remember, that is a coefficient out here. It has nothing to do with the angle in terms of being able to cancel or anything. So don't even get any bright ideas on that. So we get sine 16x divided by 2, or 1/2. This probably is easier to look at, the sine of 16x. Now, you almost have to think about the identities to just pull that off, but that's one that you recognize maybe. The next one has a question. It says, find the cosine of x over 2, or theta over 2, given the sine of theta is equal to 1/4, and theta, it says, terminates between 0 and 90, so theta's in quadrant 1. All right. Well, what's a formula for cosine of a half angle? It is plus or minus, so cosine of theta over 2 is plus or minus the square root of 1 plus the cosine of theta all over 2. You'll find that in identity formulas. Now, if theta is in quadrant 1, I need the plus because cosine is positive there. So I need to know the cosine. Well, I know the sine, I don't know the cosine. So let's get a triangle going. The sine of theta is the opposite over the hypotenuse, so 1/4. The cosine, or the x value, it's really not the cosine here, the x value is right here. X squared plus 1 equals 4 squared. So this is 16, so x squared is 15. X equals, and in this case it's positive, square root of 15, okay? So here's what we get. We get positive the square root of 1 plus, now what's the cosine? Well, it's the adjacent over the hypotenuse. So square root of 15 over 4 all over 2. Now that's not a good way to leave a fraction. So what I'm going to do is I am going to multiply the top and the bottom of this complex fraction by 4. That's the denominator that's there. Extend this out, square root actually. So 4 times 1 is 4. 4 times this is square root of 15, and 2 times 4 is 8. So we've got that. Now, I did not rationalize the denominator, but it's not too bad. It's better than it was, at least. So there are a lot of things you could do, but it's got a square root inside a square root, which is kind of a hassle to work. So I'll just leave that alone. All right, let's keep going. I'm going to change pages on you. So the next page says use a sum or difference. This is number 63. Use a sum or difference identity to find the exact value. Here's the problem. It has tangent of pi over 15 plus tangent of 4 pi over 15 all over 1 minus the tangent of pi over 15 tangent of 4 pi over 15. Now, if you recognize that, that is the tangent of u plus v, it's an identity, is tan u plus tan v over 1 minus tan u tan v. So the u in this case is pi over 15. The v is 4 pi over 15. So they match all the way through. So what this is equal to is the tangent of u plus v. So this is the tangent of, what's u? U is pi over 15 plus V is 4 pi over 15, so 4 pi over 15. So that is the tangent of 5 pi over 15, which is pi over 3. Okay, now exact value of that one, should have that one memorized. That one is the square root of 3. Okay, so exact value. Those are very helpful to have memorized. Here's one. Says find the exact value by using a half angle identity. So what's the cosine of 5 pi over 12? Well, if it says half angle identity, then this should relate to the cosine of theta over 2, which is plus or minus, we used this a few minutes ago, 1. Cosine has plus here, cosine theta all over 2. Now, if this is theta over 2 and this is theta over 2, then what's theta? Well, 5 pi over 12 equals theta over 2. So if I multiply 2 here and here, I get theta is 5 pi over 6. We know a lot about 5 pi over 6, okay? So what do we have? Well, cosine of 5 pi over 6 over 2, 5 pi over 12, is plus or minus. Now, 5 pi over 12, where is that? Well, 5 pi over 12 is less than half a pi, but it's more than 0. So this is in quadrant number 1, and the reason I care about that is because in quadrant number 1, the cosine's positive, so I'm going to use this. That's very important. Okay, so 1 plus, now what's the cosine of theta? Well, theta is 5 pi over 6. 5 pi over 6 is right here, okay? And it's got a reference angle of pi over 6. Cosine of pi over 6 is square root of 3 over 2. In quad 2, it is negative, so there. And then over 2, we have to simplify a little bit. I'm going to multiply, like I did the last one, 2 on top, 2 on bottom. So I get this. I get 1 times 2 is 2. Square root of 3 over 2 times 2 is just square root of 3. 2 times 2 is 4. Now you could actually rationalize this one easily because square root of 4 is 2. So 2 minus the square root of 3. It's hard to get the radical out of the radical, but anyway, that's pretty nice. Okay, number 65. Let's work on that one. Write secant x in terms of tangent x. Well, what's an identity that relates secant and tangent? 1 plus tangent squared x equals secant squared x. That's one of the what they call Pythagorean identities. So if I want to write secant in terms of tangent, I just need to take the square root, don't I? So plus or minus the square root. Got to be careful to take plus or minus because you don't know where it is. So there is equal to the secant of x. Now, there are other ways to do that one, but that one was the first thing that I thought about. Let's keep going. Let's see. I'm going to skip a number. There's a graph on your calculator problem. But anyway, let's verify that an equation is an identity. So let's do some identities. And I'm going to change pages on you a little bit here. So let's see how that goes. Here is our identity. It's number 68. It says the cosecant of theta plus the cotangent of theta multiplied by 1 minus the cosine of theta is equal to the sine of theta. Boy, that one looks crazy. This is the complicated side. Pretty obvious, I think. So I want it to look like sine. I am going to turn these into sines and cosines. So here's what I'm going to do. Cosecant is 1 over sine theta. plus cotangent is cosine theta over sine theta. So that's this one. This is 1 minus cosine theta. So now I'm going to multiply it out. Got this times this is 1 over sine theta plus, now this times this is cosine theta over sine theta. Then I've got minus cosine theta over sine theta. And then I've got this, I've got cosine theta over sine theta times minus cosine theta. So I've got minus cosine squared theta over sine theta. When you're verifying an identity, you do not touch the other side. Don't even try anything with that one. So first thing I notice is that that adds to 0. So I've got these two. They've got the same denominator, which is nice. So that gives me 1 minus cosine squared of theta all over sine of theta. The identity that you will probably remember the longest is sine squared plus cosine squared equals, ready, 1. Okay? So 1 minus cosine squared is sine squared. So sine squared of theta over sine of theta. Cancel one of those, you get sine of theta, and look at there, we got it. Okay, so kind of a nice result. Let's try some other ones here and see what we get. Okay, so let's look at the next one on the list here. It has tangent 4x, and it says to write that as a function of x, not a 4x. Okay, let's see what's going on. So tangent of 4x, well, that is 2 times 2x. So if you look at identities, the tangent of, I'm going to use theta here so it doesn't get too confusing. Tangent of 2 theta, identity is 2 tangent of theta over 1 minus the tangent squared of theta. So I'm going to put that in there. I'm going to put 2x in the place. So I've got this. Tangent of 4x is equal to 2 times the tangent of 2x over 1 minus the tangent squared of 2x. Now I'm not there yet because I'm supposed to write it as single x. So I've got to use 2x again. Okay, tangent of 2, now I'm going to use theta as x from this one. So I've got 2 times, I've got to have this thing, 2 tangent x over 1 minus tangent squared of x. So that one's down to x's. Now this one, 1 minus, got to have tangent squared, so I'm going to just have this one squared. What's the tangent of 2x? Well, I put x in for theta, so I've got 2 tan x over 1 minus tan squared of x. Now that is really pretty complicated, but we could work it a little bit further. Let me do a little more with it. Okay, so 2 times tangent of x is 4 tangent of x over 1 minus tangent squared of x. And then down here we've got 1, which I could put the common denominator. Why don't I do that? 1 minus tangent squared of x. So 1 minus tangent squared of x, and that's all squared because this denominator was squared. Minus, and then I've got 2 tangent of x all squared, all over 1 minus tangent squared of x, all squared. Boy, there's a lot of algebra. Now if I take the reciprocal and multiply, I've got 4 tangent x over 1 minus tangent squared of x, that's this. Now I'm going to multiply by the reciprocal of this one. 1 minus tangent squared of x, all squared. And then this one, let me do some work with it. got 1 minus tangent squared of x, all squared, minus, and I'm going to call this 4 tangent squared. 4 tangent squared of x. About off the page there. So, now, this one and this one are very much alike. I can cancel that. And I'm going to simplify a little bit. So let's come down here. We've got 4 tangent of x left in the numerator. And we've got 1 minus tangent squared. Down here, we've got a binomial that we've got to square. So I'm going to FOIL it. 1 squared is 1, minus 2 times the middle, or the first times the last, makes the middle, plus tangent to the 4th. And then that has to be minus 4 tangent squared of x. So this one and this one, that's going to make minus 6. It's not going to be that great, but anyway, a little bit simpler maybe. So 4 tan x times 1 minus tan squared of x. Here we've got 1. These two guys can go together, so minus 6 tan squared of x plus tan 4 of x. Now, I've done algebra long enough that I recognize that that is not going to factor to give me something with a 6 in the middle. I mean, that doesn't factor easily, so I'm going to call it a day on that one. Okay, so now let's deal with a couple of other problems. Now, let's take some other things. Here's one that you might like. I'm going to go to 72. It has a fill in the blank. It says blank plus sine squared of x equals 1. Now, I'm hoping that that's the easiest problem on this entire review. It is cosine squared of x. Sine squared of x plus